At 5:30 in the morning on August 7, 1945, Professor Yoshio Nishina stood on the platform at Tokyo's Tachikawa airfield. The air was still and heavy, carrying the familiar tension of a nation on the brink of total collapse. Nishina was not a soldier or a politician. He was a physicist, Japan's preeminent expert in the nascent, terrifying field of nuclear energy. For the past 4 years, he had been the reluctant head of the Imperial Japanese Army's own secretive atomic bomb effort, the NIGO project. It had been a desperate, under-resourced, and ultimately fruitless endeavor. Now, less than 24 hours after a single American bomb had, according to frantic and fractured reports, caused an entire city to cease to exist, Nishina was being sent to investigate what he and every other scientist in Japan had concluded was a practical impossibility. The summons had come hours earlier. Army officers, their faces grim, had arrived at his laboratory at the Riken Institute. The message was not a request. He was to join an investigation party, a somber collection of Army and Navy experts, and fly to Hiroshima immediately. The mission? To look upon the apocalypse and give it a name. Nishina was perhaps the only man in Japan who could truly understand the stakes. Often called the founding father of modern physics research in Japan, he was a man of international renown, a close friend and former colleague of the great Niels Bohr, having studied under him in Copenhagen. He understood the esoteric language of quantum mechanics, of fission and chain reactions. As far back as 1939, he had recognized the terrifying military potential of nuclear fission and had harbored a deep academic fear that the Americans, with their vast resources, were working on such a weapon. Now, that abstract fear seemed to have materialized as a city-sized pillar of fire. The flight to Hiroshima took 3 hours. Nishina sat with the limited information his military escorts could provide. Radio communications with the city of Hiroshima had simply stopped. At 8:16 in the morning on August 6th, the line had gone dead. The silence that followed was more terrifying than any battle report. Initial dispatches from nearby prefectures spoke of a massive, blinding explosion, of unprecedented, unthinkable destruction. Then came the American radio broadcasts, monitored by Japanese intelligence. President Truman himself, his voice cold and resolute, announced the use of a new weapon, an atomic bomb. The Americans claimed this single device possessed a destructive power equivalent to 20,000 tons of TNT. Nishina's hands, the hands of a theoretical physicist, trembled as he read the translation of those words. 20,000 tons, from a single bomb. He had done the calculations himself years ago. He knew what such a number implied. It was not merely a bigger explosion, it was a different category of energy, a force drawn from the fundamental fabric of the universe. If the Americans were telling the truth, it meant that Japan had lost a technological race that its scientists, mired in inter-service rivalries and starved of resources, hadn't even truly realized they were running. It meant that the complex theoretical calculations his own NIGO team had struggled with for years, how to enrich uranium, how to achieve critical mass, how to initiate a sustained chain reaction, had been definitively solved by American and European physicists. It meant that his own project, the Army's great hope, had been a humiliating failure. The comparison was agonizing. The entire Japanese nuclear weapons program, split between his Army project and a rival Navy effort, had been granted a combined budget that was a rounding error for the Americans. They had struggled for 4 years to acquire even trace amounts of uranium ore, their efforts in Korea, China, and Burma yielding almost nothing. Their last desperate hope, a shipment of 560 kilograms of unprocessed uranium oxide from Germany aboard the submarine U-234, had been intercepted by the Allies just months earlier. That uranium was, in all likelihood, now in American hands. His team at RECON, a small group of perhaps 100 scientists and technicians, had worked with makeshift equipment in converted laboratories. Their primary thermal diffusion apparatus, the one piece of equipment that might have separated a few precious grams of U-235, had been unceremoniously destroyed by conventional American firebombing raids in April, effectively ending the NEGO project months before this final cataclysm. Now, as the military aircraft began its descent around 9 in the morning, Nishina looked out the window and was overcome with a wave of physical illness. What he saw was not a damaged city. It was an erasure. Where a bustling metropolis of 350,000 people had stood just yesterday morning, there was nothing. There was only a flattened, reddish-brown circular scar of devastation extending for miles in every direction. A few skeletal ruins of concrete buildings remained, standing like rotten teeth in a jawbone of rubble. But the wooden structures that comprise the vast majority of Hiroshima had simply vanished, reduced to a uniform carpet of ash and debris. At the very center of the impact, he could see a dark, scorched shadow on the earth, the hypocenter of the blast. Radiating out from it were clear patterns of destruction, the signature of an overwhelming force that had expanded outwards, flattening everything in its path. He had studied theoretical physics in the quiet halls of Copenhagen. He had discussed the atom with the greatest minds of his generation. He had calculated the explosive yield of uranium-235 and plutonium-239 on a chalkboard. But seeing the physical reality of those equations manifested across square miles of an annihilated city, a city populated by his own countrymen, was something entirely different. The abstract theory had become a visceral, smoking ruin. This was the power of the atom, harnessed not for energy, but for retribution. And the Americans had done it. The aircraft landed at a military airfield miles outside the destruction zone, one of the few facilities left intact. Nishina assembled his small team of scientists and military observers. Lieutenant General Seizo Arisu, the chief of intelligence for the Imperial Japanese Army, had accompanied them. Arisu's mission was brutally simple. He was not interested in the physics. He was interested in the strategic reality. He needed to know, with absolute certainty, if this was truly an atomic bomb or some new, massive, conventional explosive. The answer would determine whether Japan had any remaining path to victory, or even survival. They entered the devastated zone in military vehicles, driving as far as the rubble-choked streets would permit. They continued on foot, stepping over charred timbers and twisted metal, the air thick with the smell of smoke and death. The destruction was total and absolute. It was a sterile, silent landscape. Buildings had not been blown apart, they had been compressed and incinerated simultaneously. Metal had melted, twisting into grotesque, surreal shapes. Shadows of incinerated humans were burned into concrete walls and steps, permanent, ghostly silhouettes of people who had been walking to work, waiting for a tram, or opening a shop just as the bomb detonated. They were the only remains of thousands, vaporized in a microsecond. Nishina began his scientific investigation immediately. He had not brought a sophisticated radiation detector. Japan possessed only a handful of such basic devices. But he had brought something far more telling. He had brought his mind, and he knew what to look for. The team made its way to the ruins of the Red Cross Hospital. Inside the rubble of what had been the radiology department, they found the first decisive piece of evidence. Lead-lined boxes containing unexposed X-ray film had been breached. Nishina held up the developed plates. They were completely black, fogged by an invisible force. This was the proof he dreaded. This was not the result of a conventional bomb. This blackening could only have been caused by an immense, instantaneous flood of penetrating radiation. X-rays, gamma rays, and neutrons pouring out from a nuclear reaction. This single discovery, more than all the visual destruction, was the decisive evidence. But he needed more. The investigation became a grim forensic exercise. The team began collecting samples. They found that various materials on the ground had themselves become radioactive. Nishina directed his team to scrape sulfur from the porcelain insulators still clinging to downed electric poles. Sulfur, when bombarded by fast neutrons, becomes phosphorus-32, a radioactive isotope. He knew that when he got this back to his laboratory in Tokyo, it would betray the unmistakable signature of fission. They collected soil samples. They collected bits of iron. And, in the most gruesome task of all, they collected bone fragments from the countless corpses littering the ground. The bones, like the sulfur, had absorbed the neutrons and had themselves become radioactive. Nishina noted the biological effects, interviewing the few survivors they could find who were coherent. These were the walking dead, dazed, naked, their skin hanging in sheets. They spoke of a decreased white blood corpuscle count, a key indicator of severe radiation poisoning. They examined the blast patterns. The bomb, Nishina calculated from the angles of the shadows and the direction of the blast waves, had not hit the ground. It had exploded approximately 600 meters above the city. This was a detail of chilling sophistication. An airburst maximized the destructive radius of the blast wave and the thermal flash, ensuring that the pressure and heat would spread over the widest possible area. The Americans hadn't simply built an atomic bomb, they had weaponized it with lethal precision. A concrete building near the hypocenter had partially survived, its walls blackened and scorched. Nishina examined the thermal damage. He noted the way granite surfaces had exfoliated, the top layers flaking off from the instantaneous, unbearable heat. He saw the bubbling on the surface of melted roof tiles. He found a charred pole and observed two distinct layers of damage, a completely carbonized outer layer and a brown, incompletely carbonized layer beneath it. From this thermal data, he made a quick, horrifying calculation. The surface temperature at the hypocenter for a fraction of a second must have reached 3,000 to 4,000 degrees Celsius. It was hot enough to vaporize human beings, to melt steel, and to ignite everything flammable within a mile radius, which had then created the subsequent firestorm that had burned for hours, completing the city's destruction. A colleague, Dr. Tsunasaburo Asada, one of the physicists from Nishina's own NIGO project, called him over. He was examining a thick, structural steel beam that had been bent like soft clay. The force required to deform structural steel in this manner was immense. Asada's preliminary calculations suggested the blast pressure at this location had exceeded 5 atmospheres, a force far beyond any conventional weapon. By noon, the case was closed. Nishina had collected sufficient, irrefutable evidence. This was unquestionably a nuclear weapon. The definitive radiation signature on the X-ray films, the induced radioactivity in the sulfur and bones, the unique thermal effects on tiles and granite, and the colossal scale of the blast pressure all confirmed it. A single uranium or plutonium bomb had been detonated 600 meters above Hiroshima. Nishina revised his initial estimate. Based on the sheer area of total destruction, he concluded the explosive yield was, at a minimum, equivalent to 10,000 tons of TNT. The Americans, it seemed, had not been exaggerating. They had achieved what Japan's entire scientific establishment had concluded was impossible during wartime. If you believe the official story isn't the full truth, you're in the right place. We dig for the facts. Subscribe to Declassified History and activate the bell for our next investigation. The team spent the rest of the afternoon documenting the impossible, interviewing the few survivors who could speak. Most were severely burned, already suffering the horrifying initial effects of radiation sickness, or wandering in a state of profound shock. They all told the same story. A blinding flash of light, brighter than 1,000 suns, followed by a wave of indescribable, searing heat. Then, a moment later, the blast wave, a roaring godlike force that knocked them unconscious and reduced the city to splinters. When they awoke, the world was gone, replaced by a dark, red twilight. One survivor, a postal worker who had been in a basement at the moment of detonation, described coming upstairs to find only shadows on the wall where his colleagues had been standing. The thermal flash had been so intense that it had bleached the concrete, leaving only the dark outlines of the human bodies that had absorbed the heat. Another survivor, a woman, showed Nishina her arms. The dark pattern of her kimono was burned directly into her skin, a permanent thermal tattoo created because the dark fabric had absorbed more heat than the light fabric. The human toll was catastrophic. Initial estimates, though impossible to verify, suggested 70,000 to 80,000 people had been killed instantly. Tens of thousands more were dying as Nishina stood there, succumbing to burns and the invisible poison of radiation. The city's medical infrastructure had been completely destroyed. Most doctors and nurses had been killed in the blast, their hospitals turned to rubble. There was no help coming. There was no way to treat the wounded. There was no capacity to even count the dead. By evening, Nishina's team had completed their field investigation. The air was cool, but the ground still radiated a sickening warmth. They returned to Tokyo on a night flight, the scientists sitting in stunned silence, the military officers visibly shaken. They arrived after midnight on August 8th, landing back in a world that had not yet seen what they had seen. Nishina went directly from the airfield to the Imperial Japanese Army headquarters to brief the senior officers on his findings. The briefing room was filled with generals, men who still spoke of decisive battles and national spirit, men who needed to understand what had happened to Hiroshima and what it meant for Japan's war effort. Nishina's presentation was technical, dispassionate, and utterly devastating. He explained nuclear fission, chain reactions, and critical mass in terms a military officer could understand. He explained that 1 kilogram of enriched uranium-235, if properly configured, could release as much energy as 20,000 tons of TNT. The Americans, he stated, had clearly succeeded in enriching uranium to weapons-grade purity. They had solved the complex engineering problem of assembling it into a critical mass, and they had detonated it above a Japanese city with precision timing. The questions from the generals came quickly. Lieutenant General Arisu pressed him for the strategic implications. Could Japan build a similar weapon? How long had America's project taken? How many such bombs might America possess? Nishina's answers crushed any remaining hope in the room. Could Japan build an atomic bomb? No, not in months, not in years. He explained that his own NIGO project had been summoned by military leadership just months before, in April, after his facilities were bombed. He had been asked if Japan could produce a bomb within 6 months. His answer then was the same as his answer now. Even 6 years would not suffice. The reason was simple. Japan lacked uranium. The industrial infrastructure, the uranium enrichment facilities, and the sheer scientific expertise required were far beyond Japan's current capabilities, which had been ravaged by years of war and incessant American bombing. How long had America's project taken? Nishina estimated that the American effort, which would later be known as the Manhattan Project, had likely taken 3 to 4 years and cost billions of dollars. He explained that the American project had almost certainly employed over 100,000 people at vast, secret facilities built from scratch in the American desert. He then delivered the humiliating comparison. Japan's NIGO project had employed fewer than 100 scientists working with makeshift equipment and almost no uranium. The Americans had spent over $2 billion. Japan's total investment in both its Army and Navy programs was 1/400th of that sum. The U.S. had built entire secret cities, Oak Ridge, Hanford, Los Alamos, dedicated to production. Japan's primary research lab at Riken had been destroyed by a conventional air raid. How many bombs did America have? Nishina could not know for certain, but the fact that they had used one on Hiroshima suggested they had more. Building a single experimental prototype was one thing. Actually deploying a weapon in warfare meant they had confidence in their production capability. America, he warned, might have 5 bombs, or 10, or dozens. And then the final, unspoken questions. Could Japan develop countermeasures? No. There was no defense against an atomic weapon. No fighter aircraft could reliably intercept the high-altitude B-29 bombers carrying them. No anti-aircraft artillery could touch them. No early warning system could provide sufficient time to evacuate an entire city. Once an atomic bomb was released, its detonation was inevitable. Could Japan retaliate? No. One general finally asked the question everyone in the room was thinking: should Japan surrender? Nishina was a scientist, not a military strategist, but his answer was implicit in every fact he had presented. If America possessed multiple atomic bombs and Japan possessed no defense and no deterrent, continued resistance was suicidal. It would not result in a glorious final battle on the beaches. It would simply result in more cities being erased one by one. Tokyo could be next, or Osaka, or Nagoya. America could annihilate Japan's population without losing a single American soldier. The briefing ended near dawn on August 8th. The generals filed out in silence, their faces ashen. The scientific truth had collided with their military pride, and the truth was absolute. Nishina's report, wired to the Prime Minister's office, landed like a mortar shell in the already divided Japanese government. The leadership was stalemated over the Potsdam Declaration, which demanded unconditional surrender and warned of prompt and utter destruction. For the peace faction, Nishina's confirmation was the final straw. Foreign Minister Shigenori Togo, upon learning of the atomic nature of the bomb, believed it was time to give up. He immediately advised the cabinet that this new weapon provided the necessary occasion for Japan to surrender on the basis of the Potsdam Declaration. Emperor Hirohito himself agreed with Togo, stating that the top priority was now an early end to the war. But the military hardliners, the very men Nishina had just briefed, refused to accept reality. They resisted. The military members of the Supreme Council for the Direction of the War pointedly avoided Premier Suzuki's summons for a meeting, costing Japan precious, irreplaceable time. The army wanted to delay any decision, arguing they needed to learn the full extent of the damage, despite Nishina's unspeakable report. Even when forced to meet, the military leaders attempted to rationalize and minimize the impact of the new weapon. War Minister Anami argued that because the Americans had thousands of B-29s, the fact that only one atomic bomb had been used meant it was likely a one-off attack and there would be no more. General Umezu argued that the United States could not possibly possess enough radioactive material to permit a continuation of atomic attacks. Admiral Soemu Toyoda, head of the Navy, delivered the most fatal miscalculation of all. He estimated that no more than 1 or 2 additional bombs could be readied. He argued that Japan should simply endure the remaining attacks and continue the war, fighting for a final, decisive battle. The cabinet remained deadlocked. A decision required unanimity, and the military refused to budge. The government persisted in its silence, paralyzed by denial, even as the radioactive ashes of Hiroshima cooled. Exhausted and profoundly shaken, Nishina returned to his laboratory at the Institute of Physical and Chemical Research. He had spent 4 years of his life trying to unlock the atom's power for Japan's military. Now, he had just examined the ruins of a city destroyed by that same power, wielded by Japan's enemy. The irony was bitter, a metallic taste in his mouth. His colleague, Dr. Bunsaku Arakatsu, approached him in the laboratory. Arakatsu was another of Japan's physics giants, a man who had studied under Albert Einstein and Ernest Rutherford. He had been leading the Imperial Japanese Navy's parallel atomic bomb project, codenamed FGO. His program, based at Kyoto Imperial University, had made even less progress than Nishina's. The two men were the heads of Japan's entire nuclear ambition. They were also intense rivals, their projects separated by the traditional, destructive animosity between the Army and the Navy. Their teams had no communication, no exchange of information. This rivalry had squandered what little intellectual capacity and resources Japan had. Now, Arakatsu, his face pale, asked Nishina if the Hiroshima bomb had truly been nuclear. Nishina didn't speak. He simply showed him the evidence, the blackened X-ray films, the radiation measurements from the sulfur samples, the blast calculations, the thermal damage analysis. The evidence was irrefutable. The two scientists, rivals no more, sat in silence, contemplating the magnitude of what they had failed to achieve and what America had accomplished. They had the theoretical knowledge. They were not inferior scientists. Nishina had calculated a critical mass of 10 kilograms of 50% enriched uranium would yield an 18-kiloton explosion, a calculation perilously close to the truth. They understood the science as well as any physicists in the world. But they both knew that understanding the theory and actually building a bomb were completely different challenges. The Americans had solved engineering problems that Japan hadn't even had the resources to attempt. Their failed projects were a testament to this gap. Nishina's NIGO project had focused on thermal diffusion. This involved converting uranium into a corrosive gas, uranium hexafluoride, and running it through a tall heated pipe to slowly separate the lighter U-235 isotope. It was an incredibly difficult process, and, as mentioned, his only apparatus had been destroyed in April, having produced exactly 0 kilograms of enriched material. Arakatsu's FGO project had pursued a different, equally difficult path: centrifugation. His team had designed a sophisticated ultracentrifuge intended to spin at 60,000 revolutions per minute to separate the isotopes. But when the war ended, the FGO project was nowhere close to success. Only the design of the machinery was complete. A prototype gas centrifuge was scheduled for completion on August 19, 1945, 4 days after Japan would formally surrender. The plutonium route was even more impossible. Creating plutonium required nuclear reactors, which in turn required enriched uranium and heavy water as a moderator. Japan had neither. America, they now knew, must have built massive production reactors at Hanford, monsters capable of producing kilograms of plutonium every month. The stories of a Japanese reactor at Riken were a myth. What Nishina had built were not reactors, but cyclotrons, a small 26-inch device and a larger 60-inch one. These were academic tools, particle accelerators used for basic data research, for measuring neutron absorption and fission cross-sections. They could produce microscopic amounts of fissile material for experiments, not kilograms for a weapon. They were tools for a university, not an arsenal. August 7, 1945, was the day these two men, the pinnacle of Japanese science, confronted the reality that they had lost a race they never had a chance of winning. America's industrial capacity, its scientific infrastructure, and its resource availability were so vastly superior that Japan's atomic program had been doomed from the very start. The NIGO and FUGO projects had been exercises in theoretical physics, not genuine attempts to build deliverable weapons. Then, on August 9th, as the Supreme Council was still deadlocked in Tokyo, the second blow fell. The second atomic bomb fell on the city of Nagasaki at 11:02 a.m. This time, Nishina didn't need to travel. He didn't need to examine the ruins. The pattern was identical. A single flash, a massive explosion, total devastation, and a city vanishing from the communications grid. The military hardliners were shattered. Their cynical theories lay in ruins. Admiral Toyota had endured his 1 or 2 bombs in the span of 3 days. America had just demonstrated, in the most brutal way possible, that it possessed multiple atomic bombs and the willingness to use them consecutively. But for the scientists, the news from Nagasaki held a final, even more terrifying revelation. As the initial reports trickled in, it became clear this bomb was different. Hiroshima had been destroyed by Little Boy, a gun-type bomb that used uranium-235. It was a relatively simple design, though it required a massive industrial effort to produce its fuel. Nagasaki was destroyed by Fat Man, a plutonium implosion bomb. This was a weapon of staggering technical complexity, a device that used precisely shaped conventional explosives to crush a subcritical sphere of plutonium into a supercritical mass. This meant that America had mastered 2 completely different, parallel pathways to the bomb. They had created an entire atomic weapons program with multiple production lines. They had the industrial might to enrich uranium on a massive scale, and they had the scientific genius to build production reactors, chemically separate plutonium, and solve the fiendishly complex physics of an implosion device. For Yoshio Nishina and Bunsaku Arakatsu, this was the final confirmation of absolute, humiliating defeat. Japan's atomic program had been playing with laboratory equipment, while America had industrialized the atom. The twin shocks, the second atomic bomb on Nagasaki, and the Soviet Union's declaration of war on August 8, which opened a new, massive front in Manchuria, finally broke the stalemate. The military's position was no longer just wrong, it was insane. Late on the night of August 9th, the emperor finally intervened, compelling the deadlocked council to accept the Potsdam Declaration. On August 15, 1945, 6 days after Nagasaki, the emperor's voice was broadcast across Japan, announcing the nation's surrender. The atomic bombs had not been the only factor, but they had been the undeniable exclamation point, demonstrating that continued resistance was not just futile, but suicidal. America could and would destroy Japanese cities one by one, without invasion, without casualties, without risk. In the post-war years, Nishina spent his time reflecting on what might have been. If Japan had started earlier, with more resources, with a unified focus, could they have built an atomic bomb? His honest assessment was no. The nation lacked the fundamental industrial capacity and, most critically, the raw materials. Even if Japanese scientists had achieved the theoretical breakthroughs simultaneously with America, translating that theory into weaponry required an infrastructure that Japan never possessed. The scientists who had failed to build the bomb now turned their attention to a new, grim field of study: the effects of the weapon on its victims. The Japanese Science Promotion Society mobilized scientists for a large-scale investigation. Recon survey teams, including Nishina's colleagues Drs. Yamasaki and Sugimoto, returned to Hiroshima from August 30th to September 6th, conducting detailed collection of soil, bones, and insulators to measure the lingering radioactivity. This was the only nuclear research the American occupation would permit. For many of the scientists, the experience turned them into active proponents for peace. Dr. Hideki Yuakawa, a brilliant physicist who had worked on Arakatsu's failed EFGO project, would go on to win the Nobel Prize and campaigned for the abolition of nuclear weapons until his death. But the final, bitter irony for Japanese science was yet to come. In November 1945, the U.S. Army occupation forces, viewing any nuclear-related equipment with suspicion, arrived at Nishina's Riken laboratory. They began to dismantle his 2 cyclotrons, the very heart of Japanese physics. Nishina protested vehemently, arguing the cyclotrons were unrelated to weapons production, that they were essential for basic biological and medical research. His protests were ignored. The cyclotrons, along with others at Osaka and Kyoto universities, were broken apart and the pieces dumped into Tokyo Bay. It was the final symbolic execution of Japan's scientific ambitions. Professor Yoshio Nishina died in 1951 from liver cancer, a disease possibly caused by his exposure to radiation during that first frantic investigation in the ruins of Hiroshima. Dr. Bunsaku Arakatsu returned to academia, continuing his research in cosmic ray physics, never working on weapons again. The NIGO and EFGO projects were dismantled, their equipment destroyed, their research files scattered. Japan's brief, futile attempt to build an atomic bomb ended in the radioactive ashes of 2 destroyed cities. The scientists who examined Hiroshima on August 7, 1945, knew immediately what the rest of the world would slowly come to realize. Nuclear weapons had fundamentally changed warfare, strategy, and the very concept of human power. The nation that possessed atomic bombs held absolute, godlike power over the nations that did not. Japan had learned this lesson in the most devastating way possible. And its scientists, the men who had understood the theory but lacked the means, carried the knowledge of their failure for the rest of their lives. That terrible gap, the chasm between knowledge and capability, had cost hundreds of thousands of Japanese lives.